Sorry, I jumped off that last video because I had a child interruption, but so the base is, this is technically x squared plus 1 to the first power. This is technically x squared plus 1 to the 1/2 power. So if you have common bases and you're multiplying, you would add the exponents of 1 plus a half, which would be 3/2. So it would be 1 over x squared plus 1 to the 3/2 power, which is the same thing as 1 over the square root of x squared plus 1 cubed. And that, I believe, is the answer in the back of the book. 55. See if I have enough room here for that. F of x equals cotangent of x over sine x. Now, I don't love cotangent. Off the top of my head, cotangent isn't one of my, strengths in the sense that I just know what the derivative of that is. So I would probably manipulate the original first to put it into something that I like. Cotangent is cosine over sine divided by sine x. So it would keep, change, flip, keeping the numerator, change division and multiplication, and flip sine to 1 over sine. And then I would see this as cosine of x over sine squared x. Oops, sorry. So one thing on sine squared x, as mathematicians, we put the squared in there, even though you really take the sine of x value first in its entirety and then square the whole thing. This does mean the same thing as cosine x over sine x squared. But if we write it that way, we have to keep sine x in parentheses. Otherwise, it looks like just the x's squared. And this is where the chain rule is going to come in, because we're going to follow the power rule first by bringing the 2 out in front, but then there's a function that's nonlinear in there that we would then have to multiply by. So you'll see that in a second. I'm going to go about this with the quotient rule first. So I have the bottom, f prime of x equals the bottom times the derivative of the top. Derivative of cosine is negative sine. So I'm going to do that. Minus the top times the derivative of the bottom. The derivative of the bottom is where the chain rule fits in here, because you always want to look at this from like a bird's eye view. Outermost perspective. This is some function being squared. So you start with the power rule and bring the 2 out in front, leave this alone and raise it to the first, and then multiply by the derivative of the function that's inside. So the derivative of the bottom is going to be 2 sine x now just to the first power times the derivative of what's inside, which is the derivative of sine is cosine. And then it's all over bottom squared, so the bottom, which is a sine squared x squared, becomes sine to the 4th x. So in cleaning this up, numerator here, negative sine cubed. This is minus 2 sine cosine squared. I can factor a sine out. I'll actually factor probably out a negative sine, which is going to drop that to a sine squared x plus 2 cosine squared x. And what I'm going to do next probably takes just experience in seeing it, but again, I get all excited when I see sine squared plus cosine squared. I don't have that, but I can break up 2 of these into plus 1 cosine squared plus 1 cosine squared. So if I see this as sine squared x plus cosine squared x plus cosine squared x and uncombine the 2 cosine squareds, this is just 1. And this sine x cancels with one of these, so it's now only to the third. So I have negative parentheses 1 plus cosine squared over sine cubed. And I believe in the back of the book they just have that distributed. So that's 55. 57, don't mind my scratch work here. 57 is y equals 4 secant x squared. Again, I think it says secant squared x, but you have to understand that that's just the secant x function squared. So outside looking in, this is 4 times the function squared. Power rule. We're going to bring the 2 out in front. So y prime is going to be 8. Leave this alone and drop the 2 down to a 1. You don't really need the 1. And then times the derivative of what's inside. And the derivative of what's inside, here's what was inside. The derivative of secant is secant x tan x. So you get 8 secant squared x times tan x. When that's all said and done, these are all technically multiplication signs in between. And then if it's all in terms of sines and cosines, this would be 1 over cosine squared times, this would be sine x over cosine x. And so you technically on the top would have 8 sine x, and on the bottom cosine cubed x. And I believe that's the answer in the back of the book. So that's 57. Let me just see where 67, 73. Where else are we, so I don't have to keep 67, 73, 63. And 33. So I'm losing track. I'm gonna have to write that 3 more times. Okay, 63 we'll do next. Just because I'm right there. Okay. Y equals 3 secant squared of pi t minus 1. Okay, I'm also going to rewrite this, again, with the squared written a little bit differently so we can fully wrap our head around what's happening here. This is the secant of pi t minus 1, and after that secant is taken, then it would be technically being squared. So that's just a different way of rewriting it. It's what this means anyway, but just so you can really see it. So bird's eye view, if I covered this up, this is 3 times some function squared. So the first thing I'm going to do is a power rule. I'm going to bring that 2 out in front. It's going to be 6 times the function raised to the first power. 6 times the function, don't touch a thing, raised to the first power, times, and I don't need that first power, the derivative of what's inside. Now this is what's inside. There's a chain rule in and amongst this, because bird's eye view, if I'm taking the derivative of this piece, this is the derivative of the secant function. The derivative of secant is secant tan. So, but then there's going to be another function within that function. There is a function within the secant function. So for now, I'm doing times the derivative of what's inside. The derivative of this, I'm treating as the derivative of a secant function, which is secant tan. So secant of this thing times tan of this thing times the derivative of what's inside of that. So there's layers. There's a function within a function within a function. So we've got a chain rule within a chain rule here. So times the derivative of just what's inside here would be times a pi. Pi t minus 1 has the derivative of pi. So now cleaning this thing up, I've got 6 times a secant of this thing times another secant of this thing times a tan of this thing times a pi. So I have 6 pi. I have secant squared of this thing times tangent of this thing. And again, with the secant and the tangent, I would maybe change the secant to 1 over cosine of this thing. And then this is sine of this thing over cosine of this thing. And then overall, your numerator is 6 pi times the sine over cosine cubed of this thing. And that's the answer in the back of the book. Oops. Okay, so that was 63. Let's move to 67. Y equals Not that you'll be taking tests, but this, in my head, if I were teaching you live, I would say, oh, pay attention because I remember one like this on tests. So this isn't the sine of something times the tangent of something. This is literally the sine of the tangent. So bird's eye view, when you initially go to take the derivative, y prime, it's a sine function, the sine of something. The derivative of sine is cosine of that something. So the first thing is to take the derivative of the sine function and make it the cosine of tangent of 2x times the derivative of what's inside. So now we take the derivative of what's inside. And the derivative of a tangent function, I believe, is a secant squared. That is me trying to remember that from last year because that's the first time I've thought of that. The derivative of tangent is a secant squared of whatever it is of, times the derivative of what's inside of that, again with the layers, and the derivative of 2x is just 2. So this ends up being 2 cosine of the tangent of 2x times secant squared of the 2x. And I just want to check to see if that's the answer in the back of the book. 2 cosine of tan of 2x times secant squared of 2x. That's the answer, was 67. 73 and 33. So 73, g of t equals e to the negative t plus e to the t all to the third. Okay, so bird's eye view, outermost perspective. This is a function cubed. So the first thing we're going to follow is the power rule, bringing your 3 out in front, leaving all that alone and dropping it to the second, times the derivative of what's inside. So the derivative of that is the derivative of this. To remind myself what the derivative of e to the x is, it's still e to the x. Yeah. So the derivative of e to the negative t is, but there's a chain rule there because there's something inside of that, is e to the negative t times the derivative of what's inside. The derivative of negative t is negative 1 plus the derivative of e to the t is e to the t. And you can also consider this as a chain rule. You take the derivative of what's inside, since there's a variable within the exponent, but the derivative of t is just times 1, so that would be somewhat pointless. So I get 3, I'm going to leave this, negative t plus e to the t squared times, I'm just going to call this negative e to the negative t, right there, plus e to the t. And that would be right, it's just, is that the same format? They have 3 e to the negative t plus e to the t squared times negative e to the negative t plus e to the t. They have these two switched, but that's fine. They do the e to the t minus this. Same thing. And then 33. Oh, okay, this one's a layered one. F of x equals brackets, parentheses, close brackets, squared. So outermost perspective, this is something squared. So the power rule, bring your 2 out in front, don't touch a thing. Technically drop to the first power, times the derivative of what's inside. So now we're going to focus on the derivative of this. So the derivative of the first piece, and then it's going to be plus the derivative of the second piece, which is just going to be a plus 1. It's the derivative of the first piece that is going to create more of a challenge. because in and of itself, there's a chain rule. It's a function being raised to the fifth power. So outermost perspective on the derivative of this part, it's something to the fifth. So we would bring that 5 out in front, leave the x squared plus 3 alone, drop it to the fourth, and multiply it by the derivative of what's inside of that. X squared plus 3 has a derivative of 2x. So that's the derivative of the first, plus the derivative of x is just plus 1. So when we go to clean this up, we have if we want to distribute this 2, we're going to have a 2x squared plus 3 to the fifth plus 2x, that there, times, this is a 10x of x squared plus 3 to the fourth plus 1. And this is a binomial times a binomial, so that would be FOILing. So I'm going to take this, when I distribute it to this term, it's going to be 20x, and then x squared plus 3 to the fifth times x squared plus 3 to the fourth is going to be x squared plus 3 to the ninth, plus 2x squared plus 3 to the fifth when I distribute to the 1. And then I take the 2x and I get after the distribution. I'm going to get 20x squared times this left over plus 2x. And that is the final answer. It's just maybe it's rearranged a bit, but there's definitely 4 components because they do FOIL out the binomial times the binomial. So, like I said, if you have more questions, try them again after you absorb all of that and see if that ironed out some of your misunderstandings. But if you still can't figure them out on your own or after talking to a classmate, again, feel free to send more questions.